Yes, sorry, I was a bit over time here. We are now ready to start our next presentation here at 10:14. So I would like to say a big welcome to Vahid Garousi, who will talk about industry academic collaborations in software testing and the lessons learned in 20 years.
Yes, hello everybody, good morning. Well, I am in GMT time, I'm in the UK. I know we have just 1 hour difference. So yes, I used to have 2 screens, but one of them is not working. So I put these things here so I can see the messages, etc. So yeah, I kind of work, so most of my work is devoted to my university job, but I also have a consulting business on the side. You perhaps, yeah, it takes about 10% of my activities. So let me start. So I will kind of give you a bit background about who I am and a review of my R&D. So the R&D projects that I have conducted with my collaborators since about 20 or more than 23 years now. And most of them have industry academic collaborations. I kind of get lots of energy and excitement when industry and academia work together. And from those, I will just give a brief snapshot of 2 of those projects in testing and test automation. And then I will share some, let's say, meta knowledge about challenges, best practices, and collaboration models that we have observed, and also from other researchers as well. So I have lived and worked in really 5 countries, and it's kind of quite an interesting international experience. I started working so this picture is from 98. I started working as a test automation engineer in 98, and we were using, I was doing manual and automated testing back then. One of the tools we were using was the classical record and playback tool called IBM Rational Functional Tester. So that was those times, and of course, many things have changed, but some things also have stayed the same. So again, teaching university courses, giving industry talks, etc., also providing consulting in these many years. So really, I get excited doing trying to improve software testing practice, doing research, and also education in university and also corporate training settings. So some of the projects that I have conducted, this is a partial list. So 2 recent ones. So one of them is called Xandar, which is an ongoing European project. It has different really work packages. One of them is verification and validation of autonomous and this real-time systems with several European partners. I was involved in a Testomat European project. Well, the project is officially over, but with those companies that we have been working on, I now provide consulting, so I should kind of say that here. And a few other projects, again, back in Turkey and also in Canada, really trying to do regression testing, multi-objective regression testing, and improving test automation practices in various ways, test the maturity and capability of different companies, and also some software inspection, etc. So the 2 projects I would like to share with you really, so one is multi-objective regression test selection, and one of them is decision support for test automation versus manual testing. So how much test automation we should do and how much manual testing, finding the right balance. So this first example project that I was involved for a few years, we had a master's student who was working in one of the defense companies in Turkey, and one of the system under test in one example was a safety critical control software, as you can see on the aircraft. So we have some metrics here, of course, given the confidentiality, but we can share. I mean, some of these information have been published already. Functionality of the SUT was defined by that many system level requirements. So it was, as you can imagine, a classic waterfall project, given the nature of the system. To verify those requirements, a large number of test suites were developed, and of course, test suites. And it was mostly manual testing with some help from test tools. I mean, such as simulators, signal monitors, etc. Again, given the domain and nature of this project. So quite a large number of test cases and test scripts were written. Again, it was mostly manual testing. And there was a need to make, let's say, regression testing more efficient and effective, as I'm going to share in the next slide. So again, I'm sure this is a classical issue for many companies. When a software fix is implemented, right, through software maintenance and evolution and regression, now it comes to the point of doing regression testing. So the customer team, so there is a contractor or test team, and then there's customer team or client. The customer will usually want the proposed regression test suite to be as large as possible, or really the so-called retest all. But the test team usually prefers to reduce the number of regression test sets to reduce their efforts, right? So essentially that's understandable, and that's what happens. And this results usually in a, let's say, in a soft way, in a conflict of objectives. So the entire approach to decide, so before our approach, so these choices were made ad hoc, subjective, and several meetings would have been required based on expert opinion, so that the two parties can decide, what's the should be large tests, regression tests, or small ones, what should be that. And again, the customer team would say, well, we need to run a large test suite to be on the safe side. We need to so again. So there was a need for a systematic, effective, and efficient regression test selection approach. And by the way, I remove that slide, but usually there's a research process. So from a method perspective, the research process and method that we use, it's usually a technology transfer and action research method. So we try to identify the challenges and problems in industrial settings, and then we go back to the research and academic literature to find, or even gray literature, to find what advances has been done in the field, in industry and academia. And if some approaches can be reused, right? So why don't we use it, or we can make customization and extensions to them. So that's our research approach. We don't try to invent the wheel always, just trying to be as efficient and as agile as possible in this collaboration. So that has been done in essentially almost in all my projects. We have followed that. So we looked at the research literature. We identified, of course, in regression testing, there's a huge research literature. Not all of them could be applied for us, but we use some of them. And we had few meetings with stakeholders, and we came to the point that we identified the number of cost and benefit factors for regression testing. And some of these are similar again to what has been done before us. So two of the cost objectives that we have identified were test execution time, and so of course that's the most obvious one usually, especially when regression tests for any reason are mostly manual. And of course, everybody always likes to increase automation. It's not always desired or even possible sometimes, because of various reasons, I'm sure you know. The second, so again, we identified 5 cost objectives. The second one here, I'm just listing 2 of them. Third-party cost. This one for testing these systems, right? So they were using in embedded system domain, again, many of our audience may be familiar with, right? There are hardware in the loop testing, software in the loop testing, model in the loop testing, process in the loop testing. And we have this XIL approach, which has about 5 or 6 types. System in the loop testing, which go through the V development lifecycle. The third-party costs, because there's certain things they had to to literally really rent out possible equipment and services from third party, and so they were non-trivial costs, and they would also increase costs on which regression test you want to run. So that had to be considered. Value, right? For regression testing, of course, you want you're going to pay some cost, but you also expect to get some value and benefit. The 2 important ones, we identified 4 objectives. 2 of them were number of detected faults. Again, one of the most important metrics for regression testing or any type of testing. And experience has shown that, well, really, right, if a test suite has detected some faults in the past, it may have some power to detect some more defects in the future. or the so-called reemergence of similar faults. Fault severity, I mean, again, similar to many contexts, we were classifying faults between 0 to 5 or 0 to 10, 10-point Likert scale, their severity. So again, test suites which have detected more severe faults in the past, it's also it makes sense to prioritize them in the next regression test suite. So these were some of the heuristics we put together. Now we have 4 or 5, we have 9 objectives, as you can see, all together. And as we can look at this problem, we try to optimize the size of minimize the size of regression testing while trying to minimize the costs and maximize the benefits. So this this turned to be a multi-objective optimization problem. For those of you who are familiar with this area of search-based software engineering, this becomes a classical search-based problem that we can solve usually, and because the constraints are nonlinear, so we have to use nonlinear and often heuristic-based approaches such as genetic algorithms. So we developed a genetic algorithm for this purpose. Again, there's lots of literature in the SPST or SPST literature. So we call the GA called MORTOGA, you know, the acronym for this thing, multi-objective regression test optimization, GA. I won't share, I mean, to keep the talk slightly high level, I won't share all the technical details, and I'm going to refer to the paper that we have about from this. Sorry. But I will share with you the structure of the so-called chromosome and gene and genome of this genetic algorithm. A gene here corresponds for test suite. So each of these things, each of the system, again, this could change by any system on the test. For this system, we had 54 test suites. Again, these were quite large scale test suites, as you saw in a few slides ago. So this binary string was the length of 54. And so one meant that that particular idea of this regression test would be in the solution regression test suite. 0 means it would not be. And so this whole thing will become a chromosome. This is a candidate regression test set, right? So we could have like 2 to the power of really 54 combinations, which is a lot of combinations. And in the GA terminology, the whole thing becomes GA population. And then you, of course, you configure the GA and let it work for a while until you get the final results, hopefully a nice result, because it's a non-deterministic approach. Anyways, the fitness function is very important. We formulated using this 2 sigma formula. Objective value was about, again, in any of those 9 objectives, right? So we had 9 objectives, this would work, and also you have a loop to go over all the genes or all tests, 54 test suites, and we need a coefficient really to consider which objectives are more important or less important. Anyways, passing over through the details, once we, of course, GA is an interesting algorithm to be developed and used, right? You have to develop it, and then you have to empirically assess how well it works. Right? It won't usually work well in the first run, so that's another story. And there are even papers on this very topic. So once we configure this and we have a sense of it that it works well. Well, of course, it's important to compare it with some other approaches. From the literature, we found one approach that was easily and directly, not easily, but directly applicable to our problem. It was called, selective requirement-based method. I think this method, selective method, and the reference in the paper, one of the highly cited papers in this area. Manual method, again, was really, for our problem, was like the before case, right? Before, so the data and how things were done before we came into develop this approach. And MORTOGA was this crossing. So that's kind of, we applied it to 5 consecutive versions of the system under test. Try to kind of measure the cost and benefit. As you can see, it was really helpful. It reduced the cost, and also it increased the benefits. In one of the versions, like this version 4, this one was slightly better than that. To be honest, I've forgotten the reason at this time, but again, the details are in the paper why this happened. We tried to, but if you put it all everything together, the new approach is better overall. Yes. So again, more details can be found in the paper that we published out of this study. Again, it was quite interesting work in which both industry and academia put their efforts together. All right. Let's look at the second, I hope I'm fine in terms of time. Second work that we did. This was a project in Canada. The challenge was test teams could not systematically decide when to automate testing and what test cases to automate. So, and we have observed this challenge really a number of companies. One such industry context was the company called Payson Corporation in Calgary, Canada. They were developing software and hardware for oil rig reservoirs. I don't know, perhaps also in the Scandinavian companies, you may have also lots of such companies, especially in Norway, I believe. So systems that would kind of, so I guess one of the systems that we applied this approach, or we developed and we applied this approach, was something called electronic drilling recorder. Again, classical rig. You have a device rotating, and then it has sensors and actuators and controllers that send all the data to back office, and they can control how it works or from the site. So very interesting and very sophisticated, and also, as you can imagine, a safety critical system. Any mistake in any software defect here can lead to disasters. So of course, lots of testing and very careful testing is needed. But of course, just like every other company and in every other team, efforts are limited for testing. Sometimes automating, and again, they have also lots of discussion on this on both academic and grey literature. Sometimes certain texts cannot be automated or should not be automated, right? So these are again very, very important discussions. Of course, we want to automate the things that shall be automated or can be automated, but there are things that are that have to be left manual for certain reasons. I mean, for Oracle problem, that expected results are not easy to be determined by automatically, etc. So how we looked at this was we laid out the classical or the generic test process, and of course, in every company there's a variation of this. The test case design phase, or even before this, you have the test planning, test case design, scripting, execution is evaluation, and then if it's pass or fail, if it's failed, you report the results in the bug repositories. Again, test case design can be done criteria-based by human or a machine, or human knowledge-based exploratory. These are the outputs, and then you have scripted tests, either automated test suites or manual test suites. And this interesting thing is that any of these 5 activities can be done either manual or automated, right, by human or by machine. So here, well, this can only be done by human because by nature this is a human activity, but this one can be done by either of them. So when you put all these things together, you have about, again, 5 activities, and then there's like binary choice for each of them, and then you can see that there's about 2 to the power of 5. It becomes like 32 combinations, which for each, so you can say for each test case, for each test suite, for each subsystem on the test, so you can look at this in different hierarchies of the system, which combination should be done in which way to give you the best outcome in terms of either return of investment of test automation, efficiency, effectiveness, any metric that you can, any suitable or important metric that you want to choose. So again, well, quite coincidentally, this problem also lended itself to genetic algorithms. Again, the previous one was a different, that was regression. This one is the decision support, quite a different issue here. But they both, we found that they were nonlinear optimization problem. So the goal is we chose return on investment, which is a widely used metric for test automation. And we can say, we said that, well, it's the benefits of test automation over manual divided by cost of automation versus manual. And I mean, we were doing black box testing for the system. That was the goal, and that's the context. So we could look at it from use case level. So we can look at it by feature level of the system that you want to do black box testing. The system had n test case use cases, and you could say, well, this use case, we can design, for example, one means we design the test cases for this use case in an automated manner. One means automated, zero means manual, scripting zero, this one 0, 0. So again, you will have this giant matrix and there will be lots of combinations inside that, as you can imagine. And then the question is, which combination, which one of those old 0 and 1 combinations in the matrix level will give me the best ROI metric? So that was the goal. We kind of, again, similarly, we designed this GA in an iterative manner, or we empirically assessed it, how it works. And then we were able to apply it to one of the systems. These are actually snapshots of some real data. There are, again, an undisclosed number of use cases. And we could look at the return on investment data. Of course, we had to measure some metrics and calibrate them to make it work. So once we analyzed the data and measured them, we looked at test design, test execution, and test evaluation, and then the other classical thinking return ROI measurement is number of test executions, right? So the more you run your automated test suite, right, you expect to get more benefits, because that's the whole point. First, you have some upfront cost to develop and design those test suites, automated one. The more you run them in regression, well, they're going to pay themselves off. So again, because of some interesting situations, after 5 iterations in terms of evaluation, some of them start to pay off. In the execution start to pay off early. So again, this were data we got from the case study. The overall ROI, I mean, when you put all this data together and normalize them, it was about 300%. So really, let's say 3 times or 4 times benefit. Automation versus manual, but of course, with these particular settings, right? If you do them other way around, you may not see benefits. So that was the interesting data that we got. Okay, and again, yeah, we published, this was a few years ago, perhaps it's almost becoming a decade ago, or let's say 7 years ago. We published, yeah, well, a few where we had 2 solutions approaches. By the way, today I shared with you the genetic algorithm version, which is this one, search-based approach. Another a solution approach that we developed and used, and I have not shared with you today, was using system dynamics. And some of you may be familiar with system dynamics. It's like a process simulation approach. So you develop, which is quite and very different than genetic algorithm, right? You develop your process, you put some bins and queues and everything else, and you make it to simulate the whole process. That was another alternative nice solution approach, and then we got some interesting data from either of them, and we shared them in these papers. Yeah, one of the authors was from industry, this gentleman from the company itself. Okay, I think I'm very good. I think I have like 6 or 7 minutes left by my clock here. Let's go to some meta level. And I will share results of the so-called systematic literature reviews from this topic that we conducted a few years ago. For those of you who are not familiar with this term, literature review, right, means we look at, again, scientific and or industrial literature or knowledge out there in internet, in YouTube videos, and white papers, whatever you can find online, credible sources. And systematic literature review, or the so-called multivocal literature review, is just putting all this knowledge together to see really what people have said about challenges of, now really we take again one meta step back, not just testing, but looking at the process and really contextual situations, that how we can make industry impact academic collaborations successful and impactful, and what are the challenges. So with these 2 gentlemen, again, quite a few years ago, in the year 2015 and 16, we conducted this study. We did a careful search and we found about 33 papers. 33 papers. By the way, many of them were from Scandinavia, I should say that, and they were from Sweden, I believe. Yeah, Sweden, Italy, means most of the authors, well, and these example papers are from Sweden. So as we know, Scandinavian countries are very active in industrial collaborations. I should congratulate you on that compared to other countries in the world, at least in software engineering. So yeah, these were like 3 of those 63 papers. So we kind of gathered data from them, and the so-called we synthesized the data. So we had a number of research questions. We also felt it was interesting to put a simplified process, a typical process for industrial academic collaborations. And really, in my own really 20+ projects in the past, it was very interesting to look at this and can remember how each of these steps worked. There's the so-called Inception Phase, right, when industry and academia come together. And one of them becomes initiator, right? It says, well, can we collaborate? Like they get to each other and they kind of communicate and they get to know each other. Like this is in the academic person, this industry person. Sometimes they are like joint. They started at the same time. There's planning phase. They say, well, what should we do? What are the objectives? Operational phase. Here, really, you review and use the literature and you develop some new stuff. And then transition phase and technology transfer phase that you contribute to a project under study in industry, and then also use it for being nice to our published papers. There are a number of challenges, success factors, patterns, and the so-called anti-patterns for any of these phases, right? There are things that we should do to make it successful, and things that if we do, there are bad stuff, right? If you do certain things, you can make things unsuccessful and people get upset, and there are motivations. So this is kind of the big picture, and there are success criteria, etc. I'll share with you a few things that we have also seen playing in this process. We identified actually a huge. We identified 10. Each of these things actually are a category. 10 categories of challenges. And then we broke down, like, I think there were like 64 challenges under 10 categories. So it was a huge list. By the way, you may ask, how did we find these things? We used thematic coding and some semantic analysis, right, to come to these things. Lack of research relevance. Of course, some of these things can be very controversial, right? So it says that some of the research done by academia may have little or low relevance. Shortage of training and experience that covered drugs. So number 4 is very interesting and important and can cause issues, right? So lack or drop of interest and commitment over time. Sometimes the commitment and interest from both sides is high, and then by time it drops or one of them drops, and then you have interesting dynamics. What are the good things that we should do? Ensure engagement and manage commitment from both sides, right? So we know that both collaborations work well, but when both sides are always excited during the whole time, during 2 years, 3 years, or 5 years that they're collaborating, what they want to collaborate. And again, the list goes on. I like also number 5, be agile. Right? If certain things happen, because life and collaborations become full of risks and unexpected events, such as COVID and so many other things. So we need to be agile, etc. Understand the context, constraints. So again, each of these things really we can talk about. Each of these things for 10 minutes or more. So I just wanted to show you the list. So yeah, I think now that's the end of my talk. 22 slides, and I think I just used my 30 minutes in a good way. So now I can take any questions.
Thank you. Most amazing, spot on time ending. So excellent. Yes. To start off, we have some questions early on in your presentation with material with I think it was an airplane test. Were all the tests you looked at functional tests, or did the test suites also include non-functional tests? I think you had 50-something test suites.
Yes. These were all functional tests, I should say. Yes, they were black box functional tests. Yes.
Yep. I personally think it was very interesting that the test teams didn't want to add more material, but the business wanted to add more, if I understood you correctly. Was there a trust reason or something for, or you
Yes,
don't
because
really know?
yeah, I should add that I think we have in the paper as well that it was but I say mainly, I mean, running all the tests were a manual process because I said it was hardware in the loop testing, right? You would essentially, each of those control units, they would connect them to some actuators and simulators in the hardware in the loop testing approach. So running the entire 54 test suites using some automated simulators, but of course the process was, let's say, mainly manual, would take a few weeks of a large test team. So it was let's say, more than 24 test engineers working full time. So that's why the test team. So when it comes to regression testing, right, the test team would not want to rerun everything in every change in the software, right? Because again, they were using heuristics such as the locality theorem, right? So you can just say, well, very, let's say, ad hoc dependency analysis. They say, well, if certain parts have changed, why should I run this part that doesn't relate to that, right? So they would, in a heuristic way, that was how it was done before. But as you can imagine, the customer team would say, let's run, I mean, a larger test suite of those 54 to be just on the safe side, right? Because you don't know, you never know what happened. So.
Okay. Thank you. We had a couple of questions on this Mortoga. In the results of that, the selective method had more benefit than the genetic algorithm
Yes.
for version 4. What's the reason for this? Is it due to changes of the system, or did your approach lose benefit over time?
To be honest, I should have looked at the paper before the meeting for that thing. I just want to be honest. I have to look at the paper myself again, but we did a root cause analysis of that and we found the reason. So to be honest, I cannot answer it now precisely, but it had something to do with the type of change that had occurred. Yeah.
Excellent. So then we refer the person asking the question to your paper and they will get an answer. And unless they don't, or if they don't, they can ping you and we can sort it offline.
Sure, yeah, they can contact me. I mean, but I think we have discussed the reason in the papers.
So in the evaluation of that Mortoga, how did you measure the benefit? Was it defined?
I mean, well, it was measured really using this, well, really the fitness function. Because the fitness function, again, I didn't share some more details of this to just keep everything at a slightly high level. So the magic lied in this coefficient. We actually used the so-called Delphi method. Some of the audience may be familiar with that. A few rounds of systematic, really, discussions, the so-called Delphi method. So the nine objectives that we have, and again, I shared just 4 of them here, just for brevity. We assigned importance, so some really coefficients, right? For example, we found, again, by meetings among the stakeholders, we found that, for example, execution time was the most important cost thing. This one was less, I mean, slightly less important because, again, we assigned the value between 0 and 1 as coefficients, and that enabled us to really quantify the objectives and their impact on the final fitness. So this coefficient was, for each 9 of them, had some value. When you add the cost, we have here the 5 cost objectives, that would be your cumulative cost for each version of the system. And when you add, using that formula, by coefficients, the 4 benefit objectives, that cumulative value will become, and so those were the values that we are showing in the chart there. Yes.
Thank you. Let's see here.
There's another question here.
Let's see here. If it doesn't add anything new, it makes no sense to run more tests. The test the same things and get the same results as before. I think that was more a comment, not a question. And so it was on our previous discussion, I think.
Yeah, as I said,
that I think this can be our last question. In the systematic literature review, how did you verify that the challenges are actually challenges and best practices in practice? How could you evaluate this just from the research papers? Or did you also do empirical studies to check that the results you found were true?
Good question. Again, by systematic, well, I don't want to praise our team, but because of our experience in conducting several or many previous SLRs before this, through our systematic search process, we identified 33 papers in this area. Again, 3 of them are here. There were like 30 more, just like as you can see. These were papers. So our criteria to choose these papers to be in the pool were any paper that was sharing anything, because our objective was to find challenges, best practices, and anti-patterns. So challenges, so really literally you just read every paper. I hope I mean, there's not much time, but I could share this. Well, I could even open some PDFs of those 33 papers. We highlighted even in colors, we color coded. So we opened the entire paper and we really read, or we just divided the work that each of us read 11 papers. Every paper and any sentence that mentioned and gave any indication of a challenge. But for example, I'm just making up a realistic example, but one paper, for example, said like this, right? For example, one said that somewhere, for example, they said like this, right? We conducted this project for a few years, and then at some point, unfortunately, or whatever reason, we observed that the commitment of academia or industry dropped a little bit. That was, we highlighted that as an example because it's just clear that that's what happened. That was something negative. That was a challenge that they observed. So we highlighted that as negative. And then this, it could be a different terminology. You know, some people say drop of commitment. Some people say drop of, or some industry partners did not attend some of the meetings, you know, something, right? So you just, and then that's the semantic analysis. Then you relate them to each other, the so-called grounded theory. So we did not do another empirical study. We relied on those papers, and those papers even have, they went through a quality check that we did. So, and that's why we believe the results are quite reliable. Yes.
Okay, thank you very much.